Now let's take a look at overloading. What I'm looking at here is the filled oval class, and I'd like to call your attention to these two methods, both named move_to, both returning nothing. And the first version of move_to has two parameters, both of type double. The second one only has one of type location. Of course, location encodes two doubles, so we expect this to do a similar thing to the other version. So let's write a similar thing for the funny face class. Okay, so here we are in the funny face class, and we're going to write another version of move_to. There's one that's already written. It takes this object and it moves it to a position that's given by the x-coordinate in the parameter minus the position of the head. So that moves it to a new position. So the beginning of this method declaration is exactly like the original one, but now we want it to take a parameter of type location. Let's call it point. We can call it whatever we like. So what do we want it to do? We want it to do the same thing that this does. In other words, we can actually use the move_to method. The difference being is that the x and the y we give it are going to be obtained by using the accessor method for the point parameter. So we just need to feed move_to point.getx and point.getY. And this should do exactly the same thing as the other version. Java accepts this because even though these methods have the same name, there's a different number and type of parameters, exactly as I showed you in the API a moment ago. So we can use this version of move_to instead of that one. Where is it used? It is used in here. Here's an example of where it's used. So instead of doing things this way, it's going to become a little awkward. So let me just comment this out. I can, instead of feeding these two arguments to move_to, I can feed it a single location argument. And this can be done by saying new location using these two values as the arguments for the location constructor. So this compiles and it works again exactly as before. Now, reading this, it doesn't look like anything is all that much better. So there's a couple of things you can do. Won't need this anymore. One thing you can do is make a local variable corresponding to this location. And notice that this random location is required in most of the branches of the if statement. You need it here, you need it there, and you need it there. You don't need it here, so what I'm about to do is not the most efficient thing in the world, but it makes things easier to read, I think. So we can define a local variable called location. Let's call it random location. And we just want it to be a new location that's given by randomly generated x-coordinate or randomly generated y-coordinate. And instead of this whole mouthful over here, I can just say random location. And I can do this in the other cases as well. That is over here, just move to the new random location, and over here as well, move to the new random location. Okay, this should compile, and it does, and there should be no difference in the way this works as well. Everything is the same. So again, we've written a different version of move to. We can invoke it. It works the same as the original one, but it's a bit more convenient because we only have to feed it one argument. And here's another example of the use of a local variable.